ladies and gents, we are moving to parallelograms. So we're going to find areas and perimeters of parallelogram. We're in page 201, exercise 3. So let's have a look at that first one. This is A. Okay? So I know that these two sides, parallelogram opposite sides, are equal. So I've got those two sides are 10, those two sides are 15. Okay? Now to find the parallelogram or the perimeter, okay, it's the same as in all the shapes. You just add all the lengths. Okay? Because remember, we're building like a fence around. Okay? So we've got 2 times 15 plus 2 times 10. Okay? 30 plus 40, we get 70 centimeters, meters, whatever we work with. Okay? It's a bit more difficult now to find the area. Okay? How do we find the area inside? What are we going to notice is that parallelogram is like a kicked. It's like a rectangle when you kicked it. Okay? So you had a rectangle, and then you just kicked it. Imagine you have like a frame of wood, and you just punched it, and it got like this. Okay? So if you straighten it up, okay, if you straighten it up, the length of this is still going to be 15, and the length of this, okay, this is not going to be 10. This is going to be less than 10. Okay, imagine if you took that, you squash the, just a second. So if you were trying to straighten it up, I'll tell you, there's an easier way of explaining. That's how I just looked in the book now. So what you can do is say, okay, what I will do is I will take this little triangle, okay, this triangle, and I'll bite him off, take it out, and I'll put him instead here. Okay, so I'll take that triangle and move it to here. Now suddenly we have a rectangle. Okay? So what would be the area of the rectangle? Ah, that's not a problem. It's simply that length, 15 times that. But what is that? It's this thing. Okay? So what is this thing? What is this thing with this line? That's the height. That's the height of a parallelogram. It's from one apex to the base opposite to it. Okay? So the area, okay, area of parallelogram, okay, is the base times height. We're going to take the base, in this case is 15, okay, get rid of that now, so it's 15 times the height. So I need to know the height, okay, I didn't write down the height for you, but according to that question, that's 8. So it's 8 times 15, not divided by 2, we're not dividing here by 2, we're just doing the base times the height, and that's going to be 120 if I'm not mistaken. Okay? And if that was centimeter, that would be centimeter squared. We all right with that? Cool. Let's do a few more complicated questions. Okay, so I'm going to do now question I, which is the same thing, but they made it a little bit more difficult for us. So we first of all find the perimeter. Okay? Perimeter is basically just adding all the lengths. Now, I've got this height is 7 meters. I won't need it for the perimeter. This is, they tell us is 1 meter, and this is 5 meters. In other words, the whole thing is 6 meters. So that's 6 meters. And here they tell us this is 900 centimeters. So this is the first obstacle, okay? We've got to decide, are we working with centimeters or meters? I think it's easier to work with meters. So 900 centimeters is 9 meters. That means this is also 9 meters. And the perimeter is going to be 9 times 2, because there's 2 of those. Plus 2 of those 6, right? That was 5 and that was 1, so altogether it's 6. So plus 6 times 2. So 12 plus 18, we gain 30 meters. Now we need to find out the area. So the area is the base times the height. Now you're going to ask yourself, which base are you using? You can either use this base, a 9, or you can use 6. Now because you're giving the height to this base, then I have to work this is the base and this is the height. If I want to work with this as a height, if I want to work this as the base, 9, then I need to find out what's the height to that base. But I don't have that. I only have this height, the 7. So I'm going to do the base, which is 6, times the height, 7, and I'm not dividing by 2. It's not a triangle, it's a parallelogram. and 6 times 7, 6 times 7 is 42, and the answer will be meters squared. Okay, let's pause again and I'll do one more properly complicated question. Okay, so we are doing now question N, which is quite difficult. I will ask you to do question M on your own, which is also difficult, probably not as difficult, but N. And what I would like to do is pause now and take 2 minutes, not more than, just have a look at N and try and see if you can do some on your own. Not finish it, just take 2 minutes. Just pause me, give N 2 minutes, and then we're going to watch the solution. Okay? So we're told that we've got a parallelogram, okay? And I know this is 1 square root 3, 1, this is square root 2. Now I'm told that this shape is a rhombus. What is a rhombus? A rhombus is a parallelogram, but all the sides are the same. All the sides are the same. Okay? And then I'm told that this is a square. So now I need to start filling what I can tell, okay? So if this is square root 3, then I know this is also square root 3, this is square root 3, this is square root 3, because this is a square. Okay? Now, if this is a rhombus, and this is square root 3, then that will be square root 3, that will be square root 3, and that will be square root 3. Okay? Now parallelogram, okay? Now I know that this is this length equal to that length. So if this is square root 3 and this is square root 3 plus 2, then that must be also 2, right? Because this length must be equal to that length. Okay? Here we have 1 plus square root 3 plus 1 is 2 plus square root 3. If this is square root 3, then that must be 2. So they will be the same. So now the only length I'm missing is this one. This is the only one I'm missing. And that will be the same as that. So I need to find that one. How would I find that one? Okay, I'm going to say, we'll call that, let's say, x. So I'm going to say x squared equal 1 squared plus square root 3 squared. So x squared equal 1, because 1 squared is 1. Square root 3 squared is 3. So x squared equal 4, which means very simply x equal 2. So this now I know is 2, and that means this one is 2 as well. Okay? So now I can find out the perimeter. The perimeter is all this solid line. Let's start from here. It's that plus that plus that plus that plus that plus that plus that. Okay? Like I build a fence around this line. It's not these dotted lines, just around. So I'm just going to write it down for you. It's going to be, let's start from here. Remember we're starting from here. So it's going to be 2 plus 2 plus 1 plus square root 3 plus 1 plus 2. Now I'm going there plus square root 3. And because I'm doing square root 3, square root 3, square root 3, let's just multiply square root 3 times 3. Okay? If you can see that, yeah. Right? So I'll leave you to do that. You just put that in the calculator. You don't need to put all in the calculator because 2 plus 2, that's 5, 6, 8. So it's 8, and then the rest you can put in the calculator. Okay? A little bit more difficult is to find out the area. Actually, it's not difficult. So as I told you, when we have a combination of shapes combined from 2 different shapes or more. So here, the combination is this rhombus plus this parallelogram. So the total area will be the area of the parallelogram plus the area of the rhombus. Let's start with the rhombus. Okay? A rhombus really is a parallelogram, just that all the sides are the same. So the area of a rhombus is the same as the area of the parallelogram. We just need to do the base and the height. So we're looking for a base with a height in it. Okay, here's the height. Okay, so the area of the parallelogram of the rhombus is square root 3 times the height. This is the base and this is the height. Square root 2. Okay? To that, we're going to add the area of the parallelogram. Okay? What is the area of the parallelogram? Well, I can take this base and time it by the height here. Okay? Or this height here. I mean, what is height? Height is a line that goes from one side to the other side and cuts it in 90 degrees. So the area is going to be square root 3 plus 2. That's the base. Okay? And we time it by the height times square root 3. Now, I mean, you can just put it all in the calculator. You can. But you can, as it is, you can put it in the calculator. But let's just practice a little bit. You know, remind ourselves some stuff about exponent. What is square root 3 times square root 2? Okay? It's the same as square root 3 times 2. Okay? Because remember, we learned our rule. If you have a bunch of stuff under the square root sign, you can split them out. There will be square root of 3 times square root 2. That means we can work backward. We can say square root 3 times square root 2 is square root of 3 times 2. Again, you can put it on the calculator, and probably that will be the easiest thing to do. But I want to just practice a little bit our roots and powers. Now, that is going to be, I can write it. You know what? I think it would just be easier if you just put it in the calculator. Okay? I can carry on and do that, but I think you've done enough. So let's just put it like this, okay? So we're going to write square root 3 times square root 2. Okay? And we're going to add, I need to, sorry. So square root 3 times square root 2 plus, okay, now here is, this is the tricky bit, okay? I need to make sure I'm not still under the square root sign, okay? So what I will do is I will do square root 3 times square root 2, and then I will press equal. And now you got a number, okay? You can see you should have square root 6 written. Now I'm going to add plus, and I'm going to open brackets, square root 3, or I will do 2 plus square root 3, close the brackets, okay? And I multiply, okay, see here we have a little bit of a problem with the way you write it. Okay. It's going to be difficult for me to do it now where you can't see it on the let me just pause it for a second. Okay, so I fiddled a bit with the calculator, and I'm just going to show you how I will do it. Hopefully you will be able to see it. Just start from the beginning. Okay, so I'm going to write, first of all, square root 3. And now the thing is, if I write time, then I will still stay under the sign, under the roots line. So I don't want to do that. So I'm going to press delete. And now before I write time, I'm going to hit that arrow. So I'm going to go to the right. And now I'm going to write time square root 3. Okay? Every time, as long as I'm still under the root sign, if I write anything, I will still be under the root sign. So I have to click on that little button saying move to the right, okay? And I see I just made a mistake, square root 2, okay? So, arrow, okay? Now I'm going to write plus, open bracket, okay? I'm going to write square root 3. Remember, again, to get out of the root sign, I need to press the arrow, okay? Plus 2, okay? Close brackets, time, square root 3. And then I just press equal. I got 8.91. Okay? If you're not sure how to do that, that's quite an important one. Working with root squares, let me know and I'll do a little, I'll work with you on WhatsApp. Have a lovely day, guys. We'll see you next lesson with trapezium.